everyone, this is Dr. D. Rajalakshmi. In today's session, we are going to see quorum-based mutual exclusion algorithms. Quorum-based mutual exclusion algorithms are different in the following two ways from the other algorithms. The first difference is a site does not request permission from all other sites but only from a subset of the sites. The second difference is a site can send out only one reply message at any time. A site can send a reply message only after it has received a release message for that previous reply message. These algorithms are based on the notion of quaternions and quorums. A quaternary C is defined as a set of sets where each set is called quorum. The following two properties hold for quorums in a quaternary. The first property is intersection property. Here, according to this property, there must be at least one common element between every quorum. The second property is minimality property. According to minimality property, there should not be any quorum which is a proper superset of the other quorum. Quaternions and quorums can be used to develop algorithms to ensure mutual exclusion in a distributed environment. A simple protocol works as follows. Let A is a site in quorum A. If A wants to invoke mutual exclusion, it requests permission from all sites in its quorum A. Every site does the same to invoke mutual exclusion. Due to the intersection property, quorum A contains at least one site that is common to the quorum of every other site. These common sites send permission to only one site at any time. Thus, mutual exclusion is guaranteed. Here, minimality property ensures efficiency rather than correctness. Markova's algorithm is a quorum-based mutual exclusion algorithm. It is working in three stages. The first stage is requesting the critical section. A site SI executes the following steps to execute the critical section. The site SI requests access to the critical section by sending a request message to all sites in its request set RI. When a site SJ receives the request message, it sends a reply message to SI provided it hasn't sent a reply message to a site since its receipt of the last release message. Otherwise, it queues up the request for later consideration. The second step is executing the critical section. The site SI executes the critical section only after it has received a reply message from every site in RI. This is the example. Here three processes are there, P1, P2, P3, and these three arrow marks are representing the progress of the three processes P1, P2 and P3. Here P1 and P2 and P3 is the request set of the process P1. The second process P2, it has the request set with elements P1 and P3, and this is what is the request set of the third process P3, and it is containing two elements P1 and P2. Now, the process P1 is requesting for the critical section execution. So, it is sending a request message to the elements that are available in its request set, to the sites that are available in the request set. So, its request set is containing only two sites, P2 and P3. So, it is sending a request message only to the sites P2 and P3. Now, after receiving the request message from P1, P2 and P3 are sending back the reply messages to P1. After receiving reply messages from both the elements or sites P2 and P3, P1 is entering into its critical section. It is executing its critical section. The first two stages are over. Now, The third stage is releasing the critical section. After execution of the critical section is over, site SI sends a release message to every site in its request set RA. When a site SJ receives a release message from site SI, it sends a reply message to the next site waiting in the queue and deletes that entry from the queue. If the queue is empty, then the site updates its state to reflect that it has not sent out any reply message since the receipt of the last release message. Here, according to our example, after completing its critical section execution, P1 is sending release messages to the sites that are available in its request set, that is P2 and P3. Now, in this way only, the McCowa's algorithm is working. Thank you.